This is the Chapter 3 Summative Assessment Review, Problems 1 through 4. For Problem 1, fill in the area model and write the area as a product and as a sum. So as a product, here are our dimensions, x plus 6 and x plus 5. So as a product, you have x plus 6 multiplied by x plus 5. You also could have written it x plus 5 multiplied by x plus 6. Either way, because of commutative property of multiplication. For example, 2 times 3 is 6 and 3 times 2 is 6. So it doesn't matter the order when you're multiplying. For the area written as a sum, we have x multiplied by x is x squared. X multiplied by 5 is 5x. 6 multiplied by x is 6x, and 6 multiplied by 5 is 30. Then we look to see if we have any like terms, and we do have two terms that are like terms, the x values. X squared, no other like terms to combine, so we have x squared. 6x plus 5x is 11x, and a positive 30 plus 30. So you have the area written as a sum, area written as a product. For problem 2a, we need to translate figure ABCD 4 units to the left and 3 units down. Or if you're going to the left, that would be x minus 4. So 4 units to the left on the x-axis, and then y minus 3, 3 units down. So for A, 4 units to the left, 1, 2, 3, 4, and 3 units down, 1, 2, 3, and we have A prime. Don't forget to put your prime mark because that distinguishes from your pre-image to your image. And then we would do that for each of the other vertices. B, 4 units to the left, 1, 2, 3, 4, and 3 units down, 1, 2, 3. And double check to make sure the length between A prime and B prime is 3, and from A prime to B prime is 2, and from A to B is 2. And you can see from B prime to C prime, 1, 2, 3, B to C, 1, 2, 3. For the second part, what are the coordinates for A prime? A prime, start at the origin, -2 on the x, and -1, 2, 3, 4, -4 on the y. So the coordinates for A prime are -2, -4. For 2b, we need to reflect figure ABCDE across x equals -1. And the way I determined how to find x equals -1 is you start at the origin, and on the x-axis you go to -1. Put a little hash mark there, and you can see that that hash mark is making a vertical line, and that's the line for x equals 1. Every x value on this line has a value of -1. For example, -1 on the x, -3 on the y. That's -1, 3. -1 on the x, 3 on the y. So all of these values equal -1. So this is our line of reflection. So if we have A from the line of reflection is -2, A prime is going to be, well, -2 units to the left, it would be +2 units to the right, A prime. B from line of reflection, 1 unit to the left. From the line of reflection, B prime, 1 unit to the right. C is on the line of reflection, so we have C and C prime share that vertice. D, 3 units to the left, D prime, 3 units to the right. It's very important that you highlight this, especially when you first started, so you don't mix it up with the y-axis. It's very easy if you don't have it highlighted to mix it up with the y-axis. But now that I have it highlighted, I know I always start on that highlighted line. What are the coordinates for A prime? A prime, start at the origin, don't start at the line of reflection, at the origin, 0, 0, 1 on the x, negative 3 on the y. For problem 2c, we need to rotate figure ABCDE about the origin 180 degrees counterclockwise. Well, it doesn't matter if we go clockwise or counterclockwise because we'll end up in the same place. If you're traveling north and you do 180 degree turn, you're now traveling south. So it doesn't matter if you do 180 degrees left or right, clockwise or counterclockwise, you're going in the opposite direction. So, but I'm going to go ahead and rotate it 180 degrees clockwise. First, I'll use patty paper. So if you're going to use patty paper, you go ahead and do the reference cross at the origin or origin cross. And you're going to go ahead and trace figure ABCDE. And then I went ahead and I traced the back side, so there's ink on the back side of it, so that way when I rotate it, it'll transfer. Then I'm going to go ahead and put my pen here, or pencil, and I'm going to rotate it 180 degrees counterclockwise. So that's right there is now 90 degrees counterclockwise. My arrow was pointing at 12 o'clock, now it's 9 o'clock. And now my arrow is pointed at 6 o'clock, it was at 12. Think of it as pointing north, now it's pointing south. And then I would go ahead and trace over my image. And then I lift it up. And I have my rotated figure 180 degrees counterclockwise. If you don't have patty paper, then you could rotate your paper 180 degrees. And I went ahead and marked my y-axis, positive arrow, and I'm going to rotate the paper. There's a 90 degree turn. One more quarter turn, there's 180 degree turn, counterclockwise. And here is my rotated image 180 degrees counterclockwise. And then what I can do is go ahead and mark down these points. So my rotated image for A prime would be at negative 2, comma 1. So I'd go ahead and write down A prime will be at negative 2, comma 1. And then I would do that for all of my coordinates. B, negative 4, positive 1. Negative 4, positive 1. And then once I have all of the coordinates, I'd rotate it back to its original position. And then I would use my coordinates that I marked down, negative 2, comma 1. There's A prime. B, negative 4, positive 1. And I would have done that for all of the other vertices on the graph. So what are the coordinates for A prime? Negative 2, comma 1. For problem 3a, I need to simplify the expression. And I have 3x cubed multiplied by 4x to the 5th. So I have, I'm going to go ahead and combine and multiply like terms. And I have 3 multiplied by 4, the coefficients. 3 multiplied by 4 is 12. And then I have x to the 3rd multiplied by x to the 5th. Well, if you remember the rule for multiplying exponents with the same base, if they have the same base, x and x, you're going to add the exponents because I'm multiplying 3x's here and I'm multiplying 5x's here. If I add those all together, I get 8x's. So I get 12x to the 8th power. Problem 3b, I have 4y third to the 2nd power. And when you have a power raised to a power, the rule is you multiply. And the way I always remind myself is, well, if this exponent smashed up against parentheses, that's reminding me to multiply. So power raised to a power, that means I have two groups of y to the third. Well, if I have 3y's multiplied by 3 more y's, total I have 6. So that's y to the 6. 3 multiplied by 2 is 6. And then I used a placeholder here for 4 to the first power. Anything to the first power is itself. So 2 multiplied by 1 is 2. And then to simplify 4 squared, 4 times 4 is 16. So we get 16y integer exponents. So here we have 9x to the 7th multiplied by 4y squared divided by 3x to the 5th multiplied by 4y to the 4th. Well, first I can divide. 9 divided by 3 is 3. And then if you remember the rule for dividing exponents with the same base, if they have the same base, you just subtract them. If I was multiplying 7x's here and 5x's here, I have more x's in the numerator. How many more? I have 2. And so basically what you're doing is you're subtracting. 7 minus 5 equals 2. Here, 4 divided by 4 is 1. And anything multiplied by 1 is itself, the identity property multiplication. So we can go ahead and eliminate that 1. And then we have y squared divided by y to the 4th. Well, I have more y's in the denominator than the numerator. And how many more do I have? I have 2 more in the denominator. So I know the y's are going to be in the denominator, y squared. 2 minus 4 equals negative 2. We can't have a negative exponent. Y to the negative second, we bring that down to the denominator, which is y to the second power. But the easiest way to remember is if you have more y's in the denominator, you know it's going to end up in the denominator. Another way of doing it, showing this, would be if I had y squared over y to the 4th power, there's y squared, y multiplied by y, and then y to the 4th is y multiplied by y 4 times. Here's a giant 1, y divided by y is 1, y divided by y is 1, and then that leaves me with y squared in the denominator. And I could multiply this by 1, so I have a value up in the denominator. So here's the answer. For problem 4a, what is the slope for any equation of a line that's parallel to the line y equals 3/4 x plus 5? Well, here's the line y equals 3/4 x plus 4. Has a slope of 3 over 4. Rise of 3 over 4. Well, any line that's parallel will have the same slope because they'll have the same rate of change. So I can create a line that's parallel to this. I'll give it the y-intercept of positive 1, and it has the same rate of change, rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. Or negative 3, 1, 2, 3, negative 4, 1, 2, 3, 4. And you can see that these two lines are parallel to one another because they have the same rate of change. Rise 3, run 4. So if they have the same rate of change, the same slope, they are parallel to each other. For problem 4b, what is the slope of any equation of a line that is perpendicular to line y equals negative 2/3 x plus 11? So perpendicular, think of the letter T. Those two lines are perpendicular to one another. They create a 90-degree angle. So if we have here's the line y equals negative 2/3 plus 11. 11 is the y-intercept, and it has a slope or rate of change of negative 2/3, rise 2, run negative 3, or negative 2, positive 3. So we want to create a line that's perpendicular, that creates a T. And it could be any line along here that's going to create that right angle. So it doesn't matter where which line I create. So I want to create a line that's going to make that T. Well, in order to do that, if you have a slope of m equals negative 2/3, a line that's perpendicular to that is going to be its negative reciprocal. So if the sign is negative, the line that's perpendicular to it is going to be a positive. And then you take the reciprocal of 2/3. The reciprocal of 2/3 is 3/2. So we have a slope of positive 3/2. And what would that look like? So if I chose any point here, and I'll choose this point right here, that has a slope of 3/2, rise 3, run 2, or negative 3, negative 2. And you can see when I connect those points, I get a line that's perpendicular. It creates these 90-degree angles. So what you need to make sure that you remember is a line that's perpendicular, the slopes have negative reciprocals. So if the slope is a positive, it'll be a negative. And then you take the reciprocal, 3/2, 2/3, or vice versa. If it's negative, it'll be positive. The reciprocal of 2/3 is 3/2.